So we set and we're about to go down, right? So today we're going to just continue from where we ended. So I have my data set here, and sake of Jacobina, I'm just going to go over very quick. So now we're going to look at what we call clustering. Now clustering, if you know what classification is, it's kind of like clustering is more like classification, but in more advanced way and in more unsupervised way. Yeah. So basically, when we say clustering, it's a way of picking up a data set and then kind of exploring the patterns, how the data points, how similar are the data, certain data points, you're grouping the data points you have. If it is, for example, patients, how is one patient very similar to the other and the other? See which patients are kind of similar. But here, unlike classification, we don't really have predefined labels or classes like classification where we would say we want to predict whether a patient has stroke disease or not, whether a patient is a male or female or something. So with classification, we know what we want. We know what we want to do. So the thing is, we want to classify, maybe images into maybe cat or dog, or images into male or female. So we have our predefined categories, or in other words, we have our independent variable and variables, and we have the dependent variable. The dependent variable is actually what we want. It can be two classes, which is the one we looked into most of the times. That is a binary classification. But we can also have more than two classes, which is more like um, that is a multi classification, or the multiple class or multi-class classification. So that one too, we can actually have that too. Now the other thing is, um, with unsupervised learning, we don't know what we want. In a way, we don't know what we want, in the sense that you don't know, you don't have a predefined class. Like, I want you to categorize these patients into sick and healthy ones or something like that. So here it is the machine or the computer itself, the algorithm, which is going to figure out, the similarities between these data points based on whatever calculation it does. So you train it and you evaluate, you train, evaluate, train, evaluate until you get, a better result, and then you are good to go. Yeah. So this is a data set. We this is what we did. We just did few things the last time. So we importing few um, libraries. We know pandas for data wrangling, matplotlib, and then Seaborn for visualizations, and then we load the data set here, and then here we do some inspections, and we can see that we have 8,068 observations and 11 variables, and then there is no duplicates in there too. And we also look at the info. We can see that we have some missing values in there, and um, we can also see that. Then we can also check, inspect where the missing values are, or how many missing values are there in each of the variables with missing values. We can see that with the variable called married, you have 140, and then that of graduate or graduated is 78, and it goes up to 829 for the experience, work experience, something like that. So now we know this, and then we just do a validation to see whether we don't have what do you call it, repetition of, kind of like uses. A disclaimer: this data set is actually in the class WhatsApp group. I sent it there, and you can have a look at it. But if you want to know what the data set is all about, it is actually customer, data set. So it is somebody's business, the kind of customers he or she has, and you can see that. So the customer ID is more like a unique ID, more like an index number or something like that, a primary key. So each customer is given a unique ID, and then it can be the let's say your number as a customer. It can be the first customer, getting the number one or second customer, or you can assign ABC or a combination of that. So it depends on the person's or the business owner's choice or way of doing it. And the gender is actually the gender of the customer. The married talks about the marriage status of the customer, where yes means married and no means not married, and the age is obviously the age of the customer. Graduated is actually a boolean variable which has yes or no, and what it does is to tell whether the customer has graduated or not. So you can see this customer, the first customer is actually not graduated, and the profession is actually about what is the profession of the person. So you can see this person works in the healthcare industry, this is an engineer, this is a lawyer, and this one works in the entertainment industry. And here we look at the work experience. So the work experience is basically about how many work experiences does the customer has, and we can see it is a float. Now it makes sense in a way. Always work experience is not measured in years, so it can be measured in even days or months. For example, if you have 1 year, 6 months, experience, that would be like 1.5 years experience. So it can be a float. But if it was a real project, I always keep saying you would consult the one who gave you the project or where you took the data from. Then you ask them, hey, how do you measure your work experience? And if they tell you that, hey, for us, all we do is to we measure it based on years, then you should know that this is not in the right data in the right data type. Guys, give me a sec. I would get back to you. So give me just like 1 minute. Let me fix something. When the light came back, my meter is beeping like it's crying, So let me check to see whether I don't know what's happening. So once I am away, you can just scroll through you can launch your Jupyter notebooks or maybe Google Chrome, and then you can load your data sets and try, catching up so that we just go. And that's it. So just 1 minute, please. So I'm back. Everything is all set. Um, and now we have our data set. If you don't know how to upload data set into Google Colab, you can probably check it out, or you can ask any of either Sandro and Nanamwa or any of. You can just check it on. You can check it on what do you call it, Google, and you'll be good to go. So for that, you're welcome. And give me a sec. I'll join again. Yeah, hello. Yeah, welcome. Yeah. Guys, I'm back. Um, Sorry about that. Where you live in Ezumbu, this is common. So let me just run my. Um, Fozan, do you have a question? Is that what? Okay, that's fine. That's cool. Thank you. So let me run all the cells to keep things up, and then we can see our data sets loaded very well. And so everything is loaded. Fine. So we did some EDA, checked the distribution of marriage status and stuff. So today, let's just because of time, for the EDA, we've always been doing the EDA, and I'm very sure, I'm very confident. You have a lot of understanding about the EDA. Maybe if I am to do an EDA, it was just be the same thing we've been doing for a while now. That's the same thing. You know, we actually have to. So you can just do it on your own, find some stuff, plot some box plots, and then some histograms, bar charts to explore the data yourself, and then it will help you understand um, the data very well. What I would like to do is, um, okay, so guys, there is a good news here. I don't know whether you've seen. Collab has just launched. They just launched AI Collab AI. So more like, let me see what it is. So Collab generative AI. This notice and our privacy policy describe how Collab handles the data. So it's more like now you can code and get more like how GitHub Copilot is like. You can code and you get suggestions in there, and it's really powerful. So you can check that out. Probably let me not do this when I finish on my actual times. I'll do that. Yeah. So here, what I want to do is enough of the listing. I want to just do some um, like a group, analysis, so that I don't spend so much time on this. So first, let me just call. If I do the f dot columns, we can see that some of the variables are actually numeric. Some of them too are boolean, like they are categorical, whether yes or no, or graduated, no, kind of categorical. So I want to kind of get all the numeric values or the numeric variables, set them aside, and then set these ones aside for a simple analysis. So if you check, we have gender. Sorry, gender is categorical, whether male or female. We have age, and then we have work experience and the family size. Yeah. So for the I told you category and then the segmentation, we are not going to use them. We'll drop them very soon. So I want to actually create a variable called. So these are actually numerics. So let me call them num calls for numeric columns, and it's I want to create a list, and the list is going to be, so I have age as one, and then if I go wrong, Charlie, you guys should alert me. So age, and then we have work experience. Let me do my usual thing. I copy and I come and paste. I don't want problems, right? And then let's pick um, family size, add it to it, and we are good to go. So if I print calls, Yeah, there are three, just three variables in there. And then let me call these ones to categorical columns. And that one is actually going to be, let me pick all these guys here and delete those that are not in. Simple. So family size is in. So, so what I'm actually doing, maybe when I start doing the analysis on them, you would understand why I'm spending my time to do that. Sometimes you may not have much time to. So work experience is in part. So let me take work experience off. It is a numerical variable. Profession is it. Age is actually numerical. Married, yeah, gender. That's cool. So if I print cat call 2, Charlie, what's happening today? Cat calls, you can see that here. So now, since I have these two, if I want to, for example, if I want to get the categorical, the numeric variables, all I'll do is df, you know, num calls instead of doing a long list. And you can see we have them here. And then the same way, if I do df cat calls, you can see that we will have those guys too in here, which is a good thing. And it's a good way to kind of do always when you don't have much time maybe to do your ED. So I'm going to grab like a code here, and then I am going to just, or let me just plot a simple, this thing. I'm not going to grab any code from it. So I'm going to do SNS of pair plots. So we've not had enough of um, the, so who knows the location and the look variable, or the look um, method rather. Let me see, num calls. Yeah. And let me see if it works. So here, what I am doing is actually I'm looking at like combination. I'm pairing the. You see, we have three the num calls. When you look at the num calls, that's the features or the variables which are actually numeric. So they are just three. I'm pairing them to plot, do analysis on them using the SNS, that is Seaborn pair plot from Seaborn, and then the df is a variable name, and I'm using the dot loc, which is like locate. The loc is a locate. It is a short form of locate variable, which is actually to say to locate things. So I'm saying that hey, go into the df, the data frame called df, and locate for me. You can see colon here and then comma. So we have two variables, two values, one value before the comma and then one value after the comma. And before the comma is actually for the rows, the number of rows you want. And then after the comma is the number of columns, or which particular columns you want. So I'm saying that if you do just a column, you're saying that everything, I want everything, I mean every row in the data set, but give me only the columns which are actually in this variable, which are in num calls, which is the age, work experience, and then family size. And then we can see this is a plot. So you can see on this vertical, sorry, horizontal axis, this is age, and then this is work experience, this is family size. Now, when you come down here, this is also age, and this is work experience, and then this is family size. So if I pick this one, for instance, you can see that the x-axis is actually age, and then the y-axis is family size. So we can see how age and then family size actually, kind of relate. And you can see that it's more like there is no so much this thing, so much relationship, between or so much strong relationship between family size and then family size and the the age. So people are young, but they are giving more birth. You can see it here. The distribution isn't really that much of a distance. Now, when you come up here to, since we are in the age, the x-axis of the age, so this is also age against work experience. Now you can see not so much significant, and then this is age against itself, age. So that is why this is a histogram, a very nice one. So that this is how the age actually, the distribution of the age. And then the same way, this is also work experience against family size. So you can see like this is a nice way to always do quick visual, I mean, quick visualizations or EDA. And let me um, explore the numeric variables in the data set. So we've at least known one thing now. Now let's see how we can also visualize the so let me copy this guy and maybe we can do that, but unfortunately we cannot do that because for the categorical variables we cannot pair them and plot, they are not numeric, so you cannot do this thing for categorical variables. So let me change this one, I'm just being lazy. Categorical variables here. So here, what we're going to do instead is to plot what we call like um, we want to plot the we want to do a value count of all those ones, plot and see. So to do that, I'll just do let's say I'll write a for loop. So let me say for v, let's say v for variable, for v in the variables it was cut calls. I want to now set a this thing of plt dot figure, more like I want to set um, a frame, a plotting frame, a size, and I want to set it to, I want to say fixed size is actually going to be, normally I like, let me go by 8 by 6, or let's just go by, I don't know, 10 by 5 and see. You can always change it. Now, after, let's run it and see whether it works. We've not plotted anything. So you can see we have actually one, two, three, four, five, lines here. So it is telling us it is working because when you print, come on, when you print the cut calls, you can see that there are actually one, two, three, four, five, variables in there. So it is telling us it is working. So now, since we've been able to iterate through it and then do this, what we're going to do is we're actually going to plot. We're going to do a value count, but we're going to use Seaborn, and you see the reason why. Seaborn has some beautiful colors, so we will use a count plot. Count plot is just like the value count. So what we're going to do is we will give the x axis or the x value, which is the one which is going to be on the x, and then it is basically going to be the v. That is, if it picks, for example, gender, it should plot gender, and then we say that the data is actually, we supply the data variables. The data is going to be df dot look, df dot look. Guys, I hope you can hear from me. I'm a little bit. Can you hear from me? Sandra, that's good. So what I'm going to say is now I want to plot the particular variable in the um, cat call variable or the categorical variables. And then the data is actually going to be df dot look. Why are we using look? We're using the location or the look because you see here we use the look um, method to actually locate certain or specific variables. So here we want every row, but we only want the cat calls because we want only that. Why? Because we just want to plot only the categorical variables. And let's see, let me suppress the output and let's run this. Hopefully it works. And boom, let me come down here and we can see that. So this is obviously gender, male, female, and then we have here married, yes, no. We have graduated, yes, no. You can see it's very nice. And then we have the professions too. Now it would be nice if we add some titles to them, to make the thing very to stand out very well. So what we're going to do is let's add. So let's do plt dot title, and we do let's format it. Let me before that let me admit Mohammed Fawzan. Mohammed Fawzan, don't worry, this class is it's being recorded. You can see, and then I'll drop the thing. It's up. So now what I'm going to do is I'm actually going to say um, the title is going to be. Let me. I hope it works. So it's going to be, or let me do it this way: distribution, distribution of. Then I do the format. So I want the format by. So if it is, for example, gender, it should do distribution by gender. If it is, let's hope if it works. If it works, you will see good. So when we come here, you can see that this plot is actually called distribution of gender. This one is distribution of married. It doesn't really make sense. At least we know there is a variable called distribution married. It should have been like distribution of marriage status, but it is still distribution of married. It makes sense to us. But obviously, if you're going to present, you would have to. So distribution of graduated, and we can see that a lot of the customers have actually graduated, and a lot of the customers have married. There is a lot of married people than this thing. There is a lot of guys too, or males than females. Then we can see that amongst the all the professions, artist professional professions actually dominate, followed by I think healthcare. Then we have entertainment. We have people around doctors and engineers and lawyers and executives and homemakers and marketing. Actually, the list. Now, when we come here to, you can see that with the spending score, most of the um, customers are actually in the low spending score, quite about half of the this thing, let's say one third of it is actually in the average, and then we have the high. Now there is a lot more you can do. I'm not going to spend so much time to do all the visualizations for you, but you can actually do a lot. You can actually do a lot, to be honest, and there is a lot more to do. You can do most of the analysis yourself. Now you are very very much okay. So you don't need to really worry that much. And now let's quickly go into, let me import, let's even before I import, let's do the um, when we do df dot head, we can see that some of these variables are actually not numeric. For example, gender, married. So let's look at ways to encode. So now we've done this over and over. Now, how can we encode gender like this? I want someone to just tell me, like this one, the Ibikuku, right? Or this one there, I think, Sandra, how can we, do you know a way, how do you suggest we go about um, cleaning, I mean, transforming the gender or the non-numeric? Pick any of them and tell us what you think. So all of us are going to pick one. So was it there you can? Sandra, are you there? Nanamwa, how do you think we can encode, for example, gender? Okay. And what about, okay, the same thing for marriage, right? And then maybe that's awesome. That's awesome. So you can use the label encoder. That's really awesome. That's true. So Nanamwa suggested something, and we can maybe look into that. He said we should use label encoder, and I'm very sure we all know what label encoder is because we've done that, right? And I'm isn't it? So Abi, all of us are cool with label encoders, right? Oh, okay, that's cool. So Nanamo suggested using a lambda function to encode the what do you call it, the numeric, or sorry, the binary, this thing, categorical variables. And then the when we come to the graduate, the profession, which is more like which is a multiple this thing, we can also develop a new way, which is maybe probably mapping. So we can map that, and we will be good to go. So that is what we're going to do. Oh, that's what we're going to do. So let's start by including maybe let me the binary categorical. So we actually encoding the binary categorical this thing. So let's look at a way. Maybe we can do. Let's first try the gender. Let's see. We can apply a lambda function, and then we can say X is actually. Let's do one for female and two for male. Come on. Else it should be two. And let's run and see whether it works. Okay, but what we should know is that we shouldn't forget some of the variables actually had missing values. So if we check that first, that will be very helpful. We can see that okay, gender we are cool. Gender doesn't have any missing values, but married has, and then the rest. So we can go ahead and let's see whether it has really worked. If we do df head, now we can see that gender is still the same because we haven't assigned it to a data frame. Where am I? So when we run this, I don't see anything. And if we come to run this, we should see the gender actually transformed. That's cool. So let's just do same for um, the rest of the categorical listing. It will not work. Yeah. So let's do for married. But um, since married has some missing values, why don't we think of how to impute the missing values before transforming it? That would be nice. So since it is categorical, always we try to do we use the mode when it is categorical. Always that is like a common thing we do, but it can change depending on the issues or maybe the kind of work you're working on or what your client actually wants. But in general, always when we have a categorical, especially binary um, classification variables, we actually or we mostly use the mode to impute. So if I do df dot married and then I do dot value count, we will see that actually a lot of people married. So let's for example do normalization and see. So you can see that over 58%, let me multiply this by 100 so that we see it clearly. Over 58%, almost 59% of the people in the or of the customers are actually married. So it's more like if you pick any customer, there is a higher probability that the person is married than not. So that is why it is always advisable, or it is always um, a convention. It is almost a convention, or we always impute with the mode because there's a high probability that the missing value will fall in that category than the other one. But that is not always the case. If it is a real project, always consult your client to know to understand the problem before you go ahead. Otherwise, you do a cost 92. So after knowing this, let's try to impute with the distance, so with the mode. So if we do df dot mode, we can see that it is actually yes, which is here the marry. And if we do 0 to get a value, we can see we get a value actually yes. That is awesome. So now we can store this in a variable called mode and let me I always like to comment transform the marriage status in the variable. So here is more like we getting the mode, and then after getting the mode, we can just do df to impute, or let me write it so that it will set as a impute the same values with the mode, and it is going to be df married. I'm not walking you through this because done these things over and over, and it's just a repetition of. So fill any if you've forgotten, and then we want to fill by the mean, the mode, sorry, and then we say that in place equal to true. Yeah, and now let's do df marry. Let's check for. So we can see, boom, no missing value, and now we can transform it. So because I've run this, if I run it again in my, okay, let me see whether it will not give any error. It didn't give any error. So now let's um, transform. So now there is no missing value. Let's just the transform the values, or rather encode, and then we can do the same the lambda listing, and we can apply a lambda function. There is a lot of ways that because of this thing, time maybe we will stick to. What am I doing? Guys, forgive me today. I'm very, very um, confused, to be honest. you know, I'm just stressed. No sleep since yesterday. But I have to, teach. I had to work on something very urgent. So that's why maybe today you are not feeling me like how I used to. If it's equal to yes, else we want it to be 0, right? For no. And let's do it. I forgot to make it 2 equal. So we can see it didn't work. Why? Probably because um, let me do a quick check to see how the values are. Copy this guy instead. Yeah, it's not working. I get it because you've not assigned it. That's all. So we have to do, and we can see it is working. So now we don't see the yes no. And if you come and run this cell here, it's going to serve as a checkpoint for us. We're actually going to, we see the married is actually here, and age, we're not going to do much about age. They graduated to, let's see, do we have actually missing values in there? Yes. So we will do same thing. We will have to impute by the um, guys. Let me copy. Allow me to copy this guy and paste even here. So we're now going to work on the graduated. So graduation. It's going to be. We'll try use find and replace. Just find. That's awesome. We want to replace with. No, it's not going to work. I'm going to ruin everything. I have to hard code it. It would create a lot of problems. All I'll do is so we're going to do impute it by the mean or the mode 2 and then okay, so if we run this guy here we should get yeah, so it's encoded. Now let's go to the professional. So with the profession, we have to first check we have some missing values in there, and we would like to. There's a lot of missing values, but let's just say we would impute with a mood. But most times when you have much more like this, you have to go to your client and ask. So you are running your business. What kind of people do you have over here? Maybe you can get some knowledge and see how you can distribute. But for learning purposes, let's impute it with a mode since it is a distance. But don't always try that. Always ask. Know further knowledge about it before you actually do something. Right. That is how we do it. So let's actually transform pre-process rather pre-process um, profession, and then we do the profession, and we do if we do dot mode, and we do 0 to get the actual mode. You see that it is artist. So most of them were artists. So maybe it might be even an artist shop that they sell some kind of artist stuff in there. That is why. Yeah. So now before even that, okay, let's probably save it as a mode. So I'm going to save this as a mode. Yeah, and then later we would impute with a mode. But now I want to create a map and then just map it with it, and I'll be good to go. So I'm going to use a different variable called a different method actually called replace. So all I'm going to do is to first, or we have to impute that first. Yeah, we have to impute. Let's impute first. Um, so someone may ask, why do I always use X? Um, This one, since it is multi challenge, we're not going to use. So I'm going to use, let me copy the code out I worked on this afternoon to just come and do to save time. So what I'm doing is I'm using the dot replace method, and I'm going to say that if the person is, it's just like creating a map and then mapping it. So this one is more like a one shot. You create the map and at the same time, map it. So if you see healthcare, replace it with one. If you see engineer, replace it with what do you call it? Two, and so on and so forth. So that is what we're going to do, and we would assign that to the DF profession. So we say that DF profession is actually equal to that, so that we see the effects. Yeah. But since we're going to transform first, let's actually impute. So same way DF profession dot fill any, and then we're going to fill with mode, and we say that in place is actually equal to true before we do the transformations. And if we do df, we can see that it has really worked. And if we run here, keep your eye on the profession, you can see it's changing from the numbers to the distance. So now when we come here to, we can just impute work experience, and then we work on these guys, and that's all. So now let's impute work experience first. So let's first impute work experience, and so when we do df work experience, and we do, so let's look at the distribution of work experience first. So that will tell us whether paste, and we can see it is heavily skewed. Most of the people have work experience between 0 and 1 than the others. So it is very good. We impute with a we impute with mean, the median, sorry, instead of the mean, because the data isn't rightly skewed, or it's not uniformly distributed. So with this being said, we can actually grab the, so let me just delete this guy here, or actually let me bring it back. Come on. So work experience, and if we do the median, you can see that the median is actually 1. So the median work experience is 1, and uh, let's call it, so median is this, and then let's do a quick this thing. Copy this guy here. Let's fill it using the fill any. Fill any. We want to fill by the median, and we want to say in place equal to true, like in a way to say yes, actually make the changes happen. And if we do SNA, I mean to check the missing values, you can see there is no missing value, so that's cool. Keep your eye on this. You see that this is NA, not a number. If I run this again, you can see that all of them tend to 1. This guy was n, not a number, now it is 1. So now the last thing to do is actually, let me, before let me, to actually encode this guy, the spending score, and then we are good to go. I think family size here also has a missing value, so okay, or let's just impute family size to first. It's not a good English. I'm going to say that is in family size. In as much as we're doing um, data science, you still have to keep your English good, right? It's very important. So family size, and let's look at the distribution. Now, maybe this may be a bit tricky, so let's get the mean and then the median first, and then plot it there to see. So this is median. This is it. This is median. And if we plot them, we plot the mean, and you see the color is actually red, and the line width is actually C2, and then the line style should be the dashes, and probably the label is the mean, and then we do same for the median. I hope I'm not confusing you guys. Now, are you confused? Because to be honest, I'm not feeling good. Just that's why I shut off my camera. Like my eyes are just turning. So if I'm speaking rubbish, guys, let me know. So now we can see, oh, let's do PLT. So we can see that the median will be appropriate. The median is actually 3, the mean is 2 point something. So let's, since it is skewed, let's use the median instead. So we're going to impute with the median. So we can, let's come here. So we know the median already. So median. So we do the family size, fill, fill any. We want to fill by the median. And we see in place actually equals true. And if we do df family size, we check the missing values in there. no missing values. And if we run this, it's acting more like a checker. Now the last thing we would encode is actually the spending score. Copy this guy. And so the spending score actually um, has no missing values. So we just go in straight encode it. Why? And the way we're going to encode it is very simple. We have to do the replace to the map. So we go into replace, and as usual, we're going to say that replace, if you see low, replace it with 1. And then if you see before even that, we don't know how many unique you know values are in there. How many unique values are even in there? So let's first check for the unique values. See, you can see that we have 3 of them here. I got them right because I've worked on that data before. But if it is new to you, you have to do and check before you go and do something that would deserve a whack. Sometimes people will scream in your face like you don't know your work, especially if you don't ask. So we want to replace, and that's all we got to do. So all we have to do is to copy this guy again, take it, and then that's so when we run this again, we can see that boom, everything is all right. Now we didn't look at this the category and segmentation because I said we're not going to add. It's more like going to give the model a clue because we don't know the categories yet. That is what we are looking for. We don't know the segmentation, so we don't want to give the model any clue. So we will drop these guys, and then for the customer ID, for anything primary key, we always drop it. It's not involved in this thing. It is just there to kind of help us understand the data and know that everything is all right. So now successfully we've been able to impute and then transform the data, and you can see that if I run this again, you're actually going to see all the values we need in here are all intact except these guys which we don't care much about. So we're not going to worry too much about them. And then let's drop now let's prepare the data for building the model. So let's actually drop unwanted columns, or let's just prepare data for model tree or something like that. So now we have to actually, mind you, it is not an unsupervised supervised learning where we have the what do you call it? The where we have the um, independent variables. Here we don't have anything like that. We feed all the data into the model just like that. So all we're going to do is, let's say we will call a variable capital X for dependent variables or um, independent variables. Here we don't have a dependent variable yet. So it is actually going to be, we're going to drop a few what am I doing, G? Forgive me, guys. So the columns actually going to be the columns we don't want. So the column like the customer ID, we're going to drop it, and then we're going to drop categories. And if you don't understand anything, Charlie, don't keep it to yourself. You pen it down and you ask me. And we're going to do segmentation, and we're going to set axis equal to 1. Let me see, place equal to 2. Or even we can even choose the 2. It doesn't really matter. If I do so beautifully, we have um, our data set for training. And if you do X of shape, we can see that it will be in the right shape. Yeah. So we actually using it is the same thing 8068, but we actually using 8 independent variables. We have a data of um, 8 variables, and we want to do clusters to know what is actually happening behind the scenes, and then know how well we can maybe work around things, something like that. Now we have our data for training or the data for the training. So the next thing is to actually build the model. So the next thing is to build the model or the model building. We have to build the model, and it is clustering. So I'm going to go all the way up to where I import my variables and import a few variables to kind of add in here. So it is these guys have finished their work. So the first this thing we're going to import is always our good friend is here. I told you um, anything machine learning is scikit-learn. So from scikit-learn dot cluster, you want to import k means. We are actually importing k means, and then that is let's run and see whether we don't get any error. We don't have any error. Boom, that's awesome. So that is the number one step. The other thing is to import things to make the model, to evaluate the model and stuff. But we're going to hold on to that first, and we're going to build the model and train the model. And it's the same as how we build and train the supervised learning models. Model is equal to k means you set the clusters and then whatever you want to do, and that's all. Now let me verify something. The way my head is just going crazy like that. If I don't verify something, I'll just pollute your minds, right? But let me pause and ask you, how is the class going? Be honest. Jacobina, am I slipping off? Am I just confusing you? But are you cool with the supervised learning? Have you done the, where did you get up to? Have you done the linear regressions? Have you done the classifications? Yeah, way, way long ago. Yeah, so probably I guess that's why, because it's kinda, um yeah, but it's fine. You're going to be fine. I don't know. I don't believe my teaching today. I feel more like I'm really really stressed, to be honest, and I have to just it's normal. I'll be fine. So guys, we're going to let me just make this thing fast and we go. Yeah. So we import k-means and or let's rather use a newer version which is more good, which is called mini batch k-means. Now the mini batch k-means and k-means, the difference is that the mini batch actually trains the model not on the entire data at once, but it takes time. You know, cuts or kind of like group the data into sub what do you call it, batches, and then take a batch at a time. It is very good for preventing or for like for model complex computational costs, to be honest, precise. So from sklearn pre-processing to, we're going to import a standard scaler. And what a standard scaler is actually going to do is to scale the data sets for us so that we don't, they be on the same scale, and it's going to help our data set. But if you take a critical look at the data set we have, for example, if you look at these guys, you can see age is actually having its own, the values for age is quite bigger. But if you look at, for example, graduated will have 1 0, married will have 1 0, gender will have 1 0, and then these guys will have one up to maybe some not up to 22 or not up to 50, and then this one to have 0 1 2 3, and then this one's to few. So if we scale them, then it will transform this data. It will just transform them into a value between 0 and 1. So now all of them will be between 0 and 1. So for example, if let's say the the biggest this thing is 100. Now um the biggest age is, or the highest age is 100. Then 22 will be like, say for example, 0.22. So which is going to be, you know it is still the same thing, but all of them will now be on the same, on the same scale. But it doesn't really affect it that much. We can still go ahead and, do without doing that. And then the other things we would import is actually, we would import from sklearn again, always importing from sklearn dot decomposition. We're actually going to import what we call PCA, principal component analysis, for dimensionality reduction. And we would also import another one, and I will explain in a minute what principal component analysis is. So another one is manifold. We want to import TS, and TSNE is more like, just like principal component analysis, and it's also a dimensionality reduction. So dimensionality reduction is more like how you can take, let's say, four-dimensional, you know, data sets, and then compress it, for example, or transform it into two-dimensional data sets. What that means is simple. Something like this. Um, you have, let's say, data set of 8 columns. Now, if you do the clustering and you want to visualize, you would visualize it using maybe, for example, a 2D chart. So how would you um, visualize 8 variables, 8 dimensional something on a 2 dimensional? So you have to condense the 8 variables into 2 variables, and then that is what the PCA and then the um, TSNE does. So they are two different algorithms, and we will see how we're going to use the same we're going to use the two of them, and we'll see which one probably does better, yeah, for us. So I just want to introduce you to, you have to know, or I mean, if you don't know now, you know, PCA means principal component analysis, and then the TSNE, you can just Google the name. I have forgotten. I don't want to tell you anything of the bar already. I am kind of going off small spot. So let's run this, and we hope it works. So now everything is all right, and we scroll all the way down, and we are good to go. So the model building. Now let me clear this guy off. You don't need it again. So now let's build the model, and I'm going to say that the model is actually the model is actually going to be um, the mini batch key means, and then we will set few parameters in here. So clusters, so n clusters. That is, now we want classification. We want to kind of like cluster our data to see the classes in the data set. How many clusters do you want? You can set any of them, and you can see when you hover on it, you can see that the um, the predefined value, or yeah, the predefined value is actually 8. So if you don't provide any this thing, the default value is going to be 8. And then there are a few other this thing we can actually give pass in here. So let's just say we want 10, um, or yeah, we want 10 clusters. We want to see 10 clusters. And what that means is that we want to classify our customers into 10 groups to see what kind of customers we have, and then a whole lot of things. So after that, we will do the n init. So the n init is more of like to tell you something like the n init is how many number of initials or initiations you should do, and then it's more like to say how many um, I mean starting points should we start from, and I'm going to set that to 10. You can um, you can see the default value is actually 1. So if you don't provide anything, it will still give you, it will be 1. You can choose not to provide, or you can choose to provide. And I'm going to give it 10. And then another thing is, since it's a random model, we have to always set seed, a random state, to any number of your favorites, so that if you run the model and rerun it again, you don't get different output, you get the same output. Now, let's train, let's look at ways to train the model. Train model, and it is very simple. We just do model dot fit. We're going to fit it with the training data which we created up here, which is x, which is stored in a variable called x. And now if I run this, I hope I don't get any error, and then boom, it has successfully run. And all I have to do now is to probably make some predictions, right? So for example, if I want to make some predictions, if I want to make predictions, I can do model dot predict, just like and let's predict the x, for instance, and let's see. So you can see, so we said we want 10 clusters. So you can see that the first person is in a cluster called 7, or the group 7. This person is in group 0. This person is in group 1. This person is in group 4. Now, mind you, when we say 10 groups, it will definitely start from 0. So we have group 0, 1, 2, 3, up to 9. That is 10 distinct groups. So you don't confuse yourself if you see 0 in here. So the 0, it's actually 0 to 9 is actually, sorry, this thing, 0 to 9 is actually 10, different or 10 distinct this thing. So let's try to append this to, let's call it gener to the x variable. So let's call it clusters, for example. Or let's do that for the training, the testing. We even have a testing data set here, so we can use that to test. But let me just do it for the training. So let me call it cluster. And I'm saying that I'm creating a new variable called cluster in the data frame called x. And then it's going to be the predicted labels. And if I do x cluster dot head, or if I do x dot head to see, we can see that now this particular customer, who is a male, not married, age 22, not graduated, who works in a profession category 1 with 1 year experience and a low spending score, family size of 4, is actually in the group 7. You can see their groups here. That's awesome. Now, let's look at ways to actually, or before then, let's look at the distinct clusters or groups we have. So if I do dot unique, and see that we actually have 0 to 9, like I said. So we have 0 here, 1 here, 2, we have 3, we have 4, 5, we have 6, and then we have 7, 8, and 9. So 10 this thing, it started from 0. So first group is group 0, we have group 1, group 2, group 3, so up to group 9, that is 10. So if you increase it to 22, it will give you 20 groups. If you decrease it to any number, then if you don't provide, the default is actually 8. Now let's look at the best way to visualize this this thing, to know what are the groups, what are the situations, and then we see. So to visualize, so let's first let's visualize clusters. Now we're going to do that with TSN first. Now before you can visualize, we want to do a scatter diagram so that we can see a very nice visualization, like of how the groups are kind of the clusters. Now you can see that we have 8 variables, independent variables here, and now we have even four, we have 8 independent variables, and then they are clusters. So how can you, and then we only have 2D and 3D, visualizations in Python. So how are you going to be able to visualize this? So you have to actually transform, you know, the or decompose the data into two components. That is what I was saying. So kind of find a way to condense the 8, you know, um, variables in the X, or the 8 independent variables into just two variables, right? And then you're going to go. So um, how we're going to do that is actually first to call the TSNA this thing. We're going to instantiate it, and then so we have TSNE, instantiate it first, and the only thing we provide is a number of components. So how many number of components, you know, I mean, that is how many number of columns do you have, do you want? So we want 2 columns because we want to do 2D visualizations, and then we just do verbose equal to 1 to say that, okay, hey, use every CPU in there, and then we're able to go. Now after that, we have to fit this thing. So tsne dot, this is how we do it, fit underscore transform, So it's going to transform our data set, the X, into two components. And then we're going to save that as, uh, let me call it, maybe let me just call them embeddings. So embedding, you can call it any name you want. And let's see if we run, you can see we see some outputs here, and so it is actually computing the thing for us. It will take some little few seconds, and then we should be good to go. Now, whilst it is doing, the next thing we will do is actually transform the embeddings or the two columns into a data frame. So to do that, so, so that we can visualize it, right? So we need to transform the embeddings into data frame. Let's allow it finish um, to finish its computing. But all we're going to do is, so transform the decomposed variables into a data frame. So that's going to be, let's call it data frame. So now it is finished. If you do embeddings, for example, if you do embedding, you can see it is some arrays. So it has converted everything. So to better see the thing, let's call it df um, embeddings, for example, embedding or df decomposed to more like to represent this decomposed, and then it's going to be pd dot data frame, and the data frame columns are actually going to be, we want to name, just let's just name them x and y, right? Since there are two columns, you can see we have two values. We have x value, then the y values. So let's just, you can choose any names for them. But since we, it is actually the a blend of or a transformed values of eight variables into two. You cannot call it maybe gender or something like that. So always we choose some unique names like x and y or a and b, something like that. And then I will say that the data set is actually the embedded, and it should work. And if I do df decomposed the head, I should see something beautiful. Now you can see this is the head. Now what I want to do is I would like to visualize this. So I want to actually add the, the clusters I predicted here. The clusters I predicted here, these guys. I want to add them, you know, to the decomposed variable. So all I'll do is decompose data frame, so df decomposed, and I want to create a new this thing called cluster, a new variable in there, which is actually going to be the clusters column or variable in the X. Simple. I think this makes sense. So I want to add the cluster or the clusters variable to the decomposed variable so that we can have like X, Y, and then the cluster so that we can visualize it very nice and we are good to go. So um, let's just do df decomposed the head and see if it worked. So now we can see here, we have it here, and that's awesome. So we have three things. and that's really cool. So we can go ahead and then visualize now. So to visualize, we would actually use um, Plotly. Let's visualize the thing, and I can't wait to visualize clusters. So we first import. I don't want to go up there. Plotly express as px. Let me see whether it would work or I have to install it. Okay, so it worked. I didn't need to install it. So the next thing to do is to do figure or fig is equal to px. I want to do a scatter diagram, and then the data frame is actually the df decomposed, and then the x is going to be the x variable. The x axis is going to have the x variable, and then the y is actually going to have the y variable, and then the color of the scatter this thing, it should be the cluster it belongs to. And so when you hover on it to when you hover we do hover data. So when you hover on the thing, we want to see the x value, the y value, and then actually the cluster to which it belongs to. And after doing this, all I have left is fig.show, and boom, it should work. It will take some time, so let's allow it to do. So now these are data sets. We can see the clusters in here. Can you see it? Guys, can you see the outline we have over there? So yeah, okay, Jacobina can see that. That's awesome. So you can see that the items, you can see like there are like some subgroups in there, right? Some subgroups. With and each subgroup or each group has one color. So you can see if I hover on this, I can see its x value is 78.34106, and then the y is negative 24.0291, and then this is the cluster 7. So these guys belong to this cluster 7. This is cluster 6. This is cluster 2. This is cluster 4. The same 4. You can see the colors are the same. This is cluster 3, 9. So these are all 9. This is cluster 8. This is cluster 1. This is cluster 5. So you can see this is cluster 0. These are the 0 guys. So we can see we have our 10 clusters in here. So let's try see whether. So 0, this is 1. Where is 2? This 2, this 3, this 4. I think 5 was around here. Yeah, Jacobina. You can go ahead. Okay, that's fine. So we can see all our 10 clusters. If you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we have 10 clusters in there. And that's actually, awesome. And now someone will ask me, so what does this, how does this make sense? Come on. Now let me, you are right. Let me, if you have this, so you can see some of the data points actually, some of the customers data points in the same distance. So what it means is that the customers in this particular cluster, for example, cluster 3, has things in common. They have the customer actually, that's a bad English, have things in common. Say, so it is up to for you to go back and then go and check and see which customer is that. So for example, if I scroll all the way up here to here, I can add another this thing. I can add another variables to it so that if I hover, I can see, for example, the person's age, the person's purchasing power, or the person's job, or something like that. So if I come here, for instance, let me check something. So I'm not sure this is going to work well. Let's try curiosity. They say kills the automata. So let me create code down here, and I'm going to add another listing. So I'm going to call it. I'm going to add this thing to the df decomposed variable. I'm going to call it. Let's see. Let's hover and um, let's kind of hover and see the customer ID, so that when we take the customer ID, or yeah, the customer ID, when we take the customer ID, we can go into the data set and see which kind of customer is that. Or better still, when we look at the DF, when we look at DF the head, we can see that we have the gender. For example, we have the marriage status, we have the age, we have the graduated, what do you call it, and then we have spending score, we have the family size. Now let's just say we want to see the gender, or there's a customer ID, because if I know the customer ID to be say this, if I come into the data set, I can search for that particular customer ID and then see, the nature of that. That will help us to actually understand. So if we hover and see in group one, get the let's say two people, for instance, their customer ID. All I'll do is to go into the data set and look at who are these people, what do they have in common, and it can help me to understand my customers and how best to help them. So, a moment I'll show you maybe one magic, right? I'll show you a data science magic. So let me call this customer ID. So I want to create a customer ID variable, which is actually going to be from the data sets. So the customer ID from the data set. And let's see whether decompose the head. Yeah, and it works. So when we come here, we want to hover on it and see also customer ID too. And if I rerun this, let's see. Okay, so when we hover, you can see we have the customer ID. So for example, this guy is customer ID 467371. 467371. So let me maybe create a column here. He is 467371. And let me look for another. Um, it was in this category, right? And then this one is 463783. 463783. So 463783. So now I'm going to look at find these guys from the data set and then see what they have in common. And let's see. So let me just even create a variable for these guys. Let me call them ID. So ID is this. And then let me just say that I want df um, where df dot customer ID is actually is in the IDs I've provided up there. And let's see. Hey, Charlie is in, and I did is in. Now these are them. So you see they were in the same district. they were in the same cluster. When you check, this one is a lady, right? This is a guy, fine. But we can see that they are all not married and they are of the same age, surprisingly. And this one is graduated, this one is not. So the female is not a graduate, but the male is a graduate, right? And then surprisingly too, they are in the same, profession. And then they have the same, health, sorry, work experience. And then they have the same spending score, which is a low one. And their family size is very, very close to each other too. So we can now see similarities between this customer and then the other. Although they are of different gender, we can see that they are of the same age and then they are all not married. So they behave, this is to tell us that these guys behave the same way. You can see they have their um, spending score to be low. So now, if for example, we want to see how best to target people, for example, which people will spend higher? How do we look for higher spending score customers? You can see that these two guys we put here are not married first, and they are in the low spending score. And again, their work experience is just 1 year, and their profession is one. Let me go and check the profession for one. Which one was marked one, so that I can. Which profession was that? Profession healthcare. So all of them are nurses. Nurse for the Omuniska. You see the thing. So it is just a joke. Sorry if you are a nurse here or any nurse who watches in future. I hope Zainab doesn't get angry. She's not a nurse, she's a doctor. But nurse for the Omuniska. It is a fact, but I hope they don't get angry. It's just a joke. So we can see that these guys are all in the same profession, which is the healthcare profession. And then they are of the same age, they are of the same marriage status, and then they have the same work experience. So if we, for example, explore or take more than, let's say, 10 people who are in that group, you will see that all of them are kind of having similar listing. Then we check their spending score. If they are all low income spending, and they are all low um, spending score customers, then it is to tell us that okay, if we are running some ads or some adverts there, we don't need to spend our time so much on the people like people who are not married, the bachelors or muniska. They, they buy gobe too much. So when you sell fried rice to them, let's say this is a fried rice shop. So you should know that these guys when they come, they only come when they have one day show. And then you can see that maybe the health we don't have to spend much time on health people because they are not the um, they are not in the high income this thing, or probably they don't spend much or something like that. So the clustering is a way to actually understand your data better, in a very very better way. And it helps you to do to know what you don't know instead of the classification, which is the other way around. You have a predefined something. So this is a simple visualization of um, clustering. Normally we visualize it like this, and then it helps us. I'm not going to do the principal component analysis, but let me just try cover that. It's just the same thing. I know the time is up. Give me 5 minutes. Let me do the principal component analysis. And we are good to go. So with the principal component analysis, just like we did for the TSNE, all you do is to instantiate it. When you instantiate, you just um, provide the end components, and then that's all. You are good to go, just like that. You don't need so much stress. So that one too, you just provide the number of components. So maybe let's create that one down here. Come on. Yeah, let's create the PCA. And then with the PCA, all we're going to do is, let me say, I instantiate it as PCA, and it is actually a PCA. All I will supply is the end components, and I want to, that's all. And the next thing is to fit it. So PCA dot fit underscore transform. So you fit and transform the X, and then that's all. So you wait for it to, and that one is a bit fast as compared to the TSNE. So let's call this decomp for decompose. So the decomp is actually my way of saying decomposition. And if we do the decomp, we can see we have them here. And let me go grab the codes up here for this guy. I don't want to do it again. So I'll convert it into a data frame. Or let me even grab all and then rerun that since it is below, there's not going to be so much of a problem. Um, we have it, and let's come add the we add this guy, then we will add the customer ID too. So let me not be selfish. So I do here composed um, customer ID. Customer ID is actually going to be the same as df customer ID. Yeah. And now when we run, you can see it's very beautiful down here. And so we have the clusters, and let's try to get this guy. So the same thing, let's run and see. Now you can see that it's not so much different from what we have up here. It's like there are slightly some almost the same. I think it's the same thing. Yeah, the same thing. I don't know if it is from my eyes. It's the same thing. So we can see very nice this thing that is very awesome. So this is how we actually do clustering. And for you to understand more, always I say I'll do my best to explain it to you how it is applicable and everything. But you have to know that for you to be the best, you have to do extra work. That is to actually learn more, practice more, and then you will be fine. So that is how we do clustering, and then that's how we also do PCA, that is or dimensionality reduction in clustering. So we've seen how PCA, which is principal component analysis, does it, and then how TSNE also does it. So at this moment, I would like to pause and then take um, your questions if there is any questions, guys. So before you even set it, the TSNE stands for T distributed stochastic neighbor embedding. T distributed stochastic neighbor embedding. That is the TSNE. T distributed stochastic neighbor embedding. You can read more on that. If you go to, if you just type TSNE meaning on Google or any search browser, the first link is actually Wikipedia, which is the world's encyclopedia, right? You can have a lot more to read on there. Now, guys, your questions. Any questions? Any questions? Yeah, Sandra, you can go ahead. So, don't be confused, please. So, the clustering, let me go way back in the 80s, right? So before we even did the dimensionality reduction, we first make the predictions. We built the model. I hope that one you know and you understand, right? So we built the model here, and then just like we do all the time, and then we actually made predictions, and then we added the predictions as a column, or a variable to the data. Mind you, the x is actually the data we created for the model, the transformed one, which includes only the relevant columns we want. And then we added it to it, and you can see it here. So it means that um, this particular customer has or belongs to the column or the cluster 7. This one belongs to 0. So the model did the clustering. Now when we came here to visualize the thing for us to see or to make it nice, we cannot visualize or we cannot plot, 7 dimensions or 8 dimensions. The farthest we can go in Python is actually 3 dimensions. Even in mathematics, I understand people are trying to do 4 dimensions, 5 dimensions. It exists. I mean, million, even it is nth dimension. I mean, you can do, but to visualize, you are limited in a way. So we can only do 2D and 3D visualizations in Python. So we have to find a way to condense, instead of just picking any of the two variables, which doesn't make sense because we use all of them to predict the cluster. So what we will do rather is to use a technique called dimensionality reduction, more like calculus. You pick, it is basically calculus. It's indeed calculus. So you pick the values and then you kind of do gradient descent. So you bring them down and you can specify the number of, kind of like condense them down into the number of columns you want or variables you want. And for me, I said I want two because I want to do a 2D printing, sorry, 2D visualizations. That is a scatter plot. So I need an x and y and variable, and then that is why I did. So that is what the TSNE and then the PCA does. So you can see that here we are actually fitting it on the x, right? On the x to say like, hey, transform the data I use for training. Instead of having 8 variables, I want you to actually let it condense everything into just 2 variables. So it would know how it does its calculations or to bring them down, put them together into that. But TSNE and then PCA are two different, they do the same job. It's just like one solution but two different formulas, right? TSNE, to be honest, it's more complex, way complex, and it is very good for very complex situations. So if you have a very complex data set, you can go with the TSNE. Where PCA is actually very simple. And you could see even from the fitting, when we fitted it, you could see this one took much time to do, but the PCA was just very fast. Now, when we transform the data sets into the two, or when we decompose them into two variables, we say we want to create a data frame, and then we want to call we want to call the two variables x and y. You can choose to give any name you want. You can choose to give positive, negative, Dora and Dorigin, or whichever one you want. But for me, for simplicity's sake, I just choose X and Y because I'm going to plot, and I just don't want to confuse myself. And mind you, the reason why we didn't use any variable name from the X variable, maybe to say gender or something, is that it is not. You see the X, when you see the X value, it comprises of more like four, it comprises of four or more variables. So it's like a blend of variables. That is why you can see we even have negatives in here. So how it does the mathematics, only artificial intelligence knows, and only mathematics knows. And if you want to know, I'm joking, if you want to know, you can read more about that. But I cannot tell you now. You can just search on YouTube how PCA works. It's calculus. PCA and SNE uses calculus to decompose vector decomposition. Yes, so we are all mathematics guys, and we did vector decomposition. So more like a way to decompose a vector of higher dimension to a smaller dimension. Yeah, so that is what it does, and then make it we kind of transform it in a data frame for easy this thing. And then we go and pull from the X, that is the training data set, the clusters we actually did. That clusters the model predicted. So we go into, we went to pull them. So now it is more like, see it like this. It is more like, you see this data set with the clusters. Um, we're going to pick, let's say it's like we've picked the first four. Yeah, I hope, yeah, this is the first four. So these first four variables here, and then we are calling them x. So all of this is what is x. It is just an example I'm giving. I'm not saying it is so. And then the the next ones, that is profession, blah blah blah, up to this guy is the last four. Two, we want to call them y. Right. So it is like this. So now, if you have this, you can see that we will now have x, y, and then the clusters. And that is what we have down here. So let me scroll. That is what we have down here, these guys. So you can see the x is actually the four, let's say the first four values, the condensed or the decomposed first four values, and then the y is the decomposed, and then the cluster is the clusters of it. So that is basically how it does. So I don't know whether I've been able to answer your question, um, Sandra, or you confusing. I'm confusing. Okay, she's Sandra. You went off. Um, I have done the explanation. I'm very sure you had some of it. Are you convinced now? Are you okay now? Sandra, are you there? So whilst you wait for Sandra, guys, any question? Any of you who has a question can just ask. Come, let me clean this guy. I didn't fit the model in a PC, please. We transform the data with a PC, point of correction. We fit, yeah, before you do. So this is the TSNE. We do, I first, I imported from manifold, I imported TSN, this guy, the capital. And then I'm instantiating it just like when you import, for example, linear regression. You do model is equal to linear regression. So I'm saying that, okay, I'm calling it in a smaller distance, TSN is equal to this. Now I supply the two parameters, that is um, end components and then the verbose. Verbose is optional. You can just do end components and it will work. What the end components means is that now you have a data set you want to transform. How many? So the eight variables. How many columns do you want out of the decomposition? So I want two columns to say. In other words, to say that transform the eight columns into two columns. So if I had done three, it would have done. It would have transformed the eight columns into three columns. And the same way, so when you finish, you have to fit. So dot fit underscore transform. You see, it is not doctrine because it's not a model. It is fitting, it is transformation, pre-processing, just like we did the oversampling and undersampling, just like that. So when you do that, it will do some calculations and get you the arrays. And I'm actually storing that in a variable called embedding. You can call it any way you want. And then um, when I come down here, I convert the values I have into actually so into actually a data frame for easy work. So if I do, for example, you want to see the embedding, how the embedding is like, you can see that it is an array. You see it of two pairs. So the X, Y for the first customer, and then this is the XY value for the second customer, so on and so forth. So this is when it is like this, it becomes very difficult to see. It's more like human, not good for the human eye. I mean, to read and understand. But when it is in the normal this thing, um, data frame like this, it makes it very very easy. That is why we transform it into that. And now I hope so. Let me go back. Let me go down to the PCA tool. You see how I fitted the PCA. So the PCA, the same thing. You see, I didn't even provide any variables. I just did n components equal to 2. That's all. And I fit transform. And I'm like, are you cool? I should wait. Okay, so whilst we wait for Nanamwa, Jacobina, are you more confused now? Or you are a little bit okay now? Yeah, when you watch the videos on the classifications and regressions, or maybe when you watch any video, you would understand. It is very simple and yet more robust and life saving. Right? And for you, I will entreat you to really take it serious because actually, I've what the by hook or crook, if you don't predict something in your final year, then you're actually plan. If you like, ask Sandra and she will tell you. Sandra, is that not true? You don't. Okay, Sandra. Okay. Uh-huh. Yeah, it's simple. Yeah, that one. So that was what is worrying you, right? Yeah, it's cool. It's good, but it's not going to change anything. You get it? Yeah, probably it might have an effect on the this thing, but the same concept. It's a printing mistake. It's a printing mistake. So this is a weird thing we've had. So the PCA didn't work. What the hell is this? And I'm on the assembly bar. So this is the kind of class that we have. So it's more like the PCA probably didn't do the work, or I didn't do the work well since I just changed something. So you can, it's the same this thing. When you change and rerun it, it will be better because we already ran some of them and we are running this. That's why it's bringing the confusions. But you can just run and then get. you will get the same thing as the what do you call it, as this guy is here, yeah, or something very similar. And then if you don't get, then it means that the PCA isn't the correct algorithm, you know, for this. It is not printing, or it is not condensing them very well. So like I told you, the TSNE is more robust. But to be honest, when I did it in the daytime, I had the same thing. So it's just because I've been running some of them for a while. But don't worry, it's nothing. When you try and it doesn't work, it means that the one which gives you the best result is always the best, right? That's machine learning. Any questions? Sandra, you were saying you were about to say something. Yeah, it's about. Okay, go ahead. Yeah, all I say. Yeah, and even this scatter close to. I think that should be from your what you're looking for. For example, for this data set, you can say I'm looking for outliers in the age variable. So you can just do scatter plot, and then you see that some of the age variables are very extreme, whether extremely high or extremely low. You can also do even a box plot, and you see some of them out of the whiskers, or maybe a histogram and see it is kind of skewed, some weird values, either extreme low or extreme high. You get it? So you can do it variable wise. Normally that's it. You do it variable wise and then see, or if you want to do it at a high level like this too, like what we've visualized here, you can see that it's like although they are in groups, but these groups are kind of also close to each other. We don't have any group which is way like very very far away from all the other groups. So if we had that, then we will say that okay, we have some customers who are actually extreme, like who are outliers, in a way, with all due respect, in a sense that maybe they don't have even a buying pattern. Today they touch jollof, the next day they touch banku. You know, they don't have regular times they shop. Like they are just random people like myself here. You get it. So outliers detection is actually the I think the project wise, whatever the project demands you. But if you are investigating an outlier in the variables, you can do it variable wise. But if let's say the concept higher level one, which is like more like inferential, for example, with the customers, you want to see like it is an implicit something. You want to see, do we have like outliers in our customers? For example, when you visualize this, you can see that fine, they are cool here, and and we can see all the clusters are not really. We don't have a cluster which is way like far away from the entire data set. You can see the groups are kind of close to each other. So we don't really have extreme or weird customers in it. I don't know whether I answer your question, or maybe I'm just speaking bullshit. Sandra, do I answer your question? Yes, Sandra, welcome you. What I was trying to say is that you can do it either project wise, sorry, um, variable wise. For example, with this data set, you can say, I want to see, do you have outliers in the age variable? Do you have outliers in the family size variable? Do you have outliers in the experience level? Because maybe you can see that almost 90% of the customers have experience level between, let's say, 0 and 20. And there is this person who is saying his experience level is 56 years. You get it? All of a sudden. So he is like an outlier. You can investigate into that. Or you can also investigate into maybe the age. You see somebody who will say, oh, me, I'm 100, 500 years old. In this uh, 21st century, there is no Methuselah. So no one is 500. So you can actually do variable wise, this thing, outlier detection, and you can, or anomaly detection in another this thing. And you can use scatter plots like we've done. You can use histograms, you can use box plots, for example, and determine whether to take those ones off or to kind of like standardize the data or something like that. And if you want to also do it on high level like this, that is the inferential part of it, you have to, with this one, if you want to use this to detect, for example, do we have customers who are weird anomalies, who are outliers, then when you do the visualizations, you will see that a particular group will be very, very far away from the rest of the groups in the data set. But here we can see that the groups are very, the observations or customers or the data points in one group are very close to each other, but they are not really also very, very far from the other groups. So you can see there is no group which is way, 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 way far away from the other groups. So here, that is another way to also check. So we have the variable level or the implied or the implicit or the inferential or the higher level one. I don't know whether you get it now, or maybe I didn't get it. Yeah, sure. I am being signaled that some people are hungry. So if you have a question, fast, fast, then go. Today we've overspent time. Sorry about that. It happens sometimes. Any questions? Sandra? Yeah, that's true. It's more like, let me give this scenario. If you want to marry a woman, or let me be in your shoes, if you want to marry a guy tells you, Sandra, I like you. Let me go and see your family. You validate things, right? You have your own criteria. That's about the English criteria you actually go into. So I may have, or let's say Jacobina may have her own criteria because she is a different person from you. Maybe you would say if you don't have beards, red flag, or maybe you have too much beards, red flag. If you are the outgoing type, red flag. You get it. So every scenario has its benchmarks for evaluating it. So when you come to university, there is an evaluation metric. The exams in university is different from high school and that of um, the previous ones. So the same way, linear regression is trying to predict continuous values. So to evaluate how accurate the thing is. So linear regression, we actually use the mean absolute error, not just the mean absolute. Yeah, we use the error, which can be the mean absolute error, mean squared error, root squared error, mean absolute percentage error. So basically, the error that is we are trying to, for example, predict the temperature for today. So if I predict, say, 29 degrees Celsius as the Celsius as the average daily temperature for today, and then the when we actually witness today, we realize that the thermometer recorded 30. Then you for you to believe or to accept this model, you look at what is the gap, between the true value and then the model's prediction. So we want a model which is which predicts as close to the truth value as possible. So a model with a linear regression model with a very low error is the best. But when it comes to classification, we are not predicting a continuous value. And we're actually classifying, you know, observations into categories. Whether is this black, white, is this. So we cannot use the maybe mean absolute error, for instance, or the error this thing. It has an error there, but its error is not to be measured like mean absolute error. But you can measure like accuracy. How accurate when I predict this is a female, how accurate is my prediction? So if I have a higher accuracy, then you can trust me. And then we have other ones, not just accuracy. We have the F1 score, we have the recall, we have the AUC, ROC, we have a lot of things. So the same way when you go to NLP2, you can see, um, you can actually look at benchmarks like, for example, LLMs, the ChatGPT use, we evaluate them, and then we evaluate them on metrics like MMLU, KiloSwag, a lot of them, in the accuracy, hallucinations, and all those things. We check all those before um, they are released. So every case has its metrics or evaluation metrics. Yeah, and you saw that in the work we did. I think Ipogena is tied, and Amwa is also tied. Sandra Iku, you're welcome. Any other questions? I think we are okay. Yeah. So if there is no question, I would like to thank you for coming today. And we've done. There is not so much to do under clustering. So we've looked at the clustering. There's also much to do under classification. We've looked at clustering, and we've also looked at dimensionality reduction using PC and then TSNE. Now it is left with you to practice, to read more. We didn't even evaluate the model on the testing, on the test set.csv. So you can import that, and then you do the dimensionality, whatever, make predictions with the model, and then you are good to go. And now you have to also search for some of the metrics to evaluate the performance of the clustering model. We didn't cover that. It's just a Google, just type Coropa, and then that's it. You are good to go. And I like I said before, the next thing we'll be moving on to is actually a time series, like time series analysis, and then we wrap up with um, deep learning, and we get your sets and we go, so that I can also go and enjoy myself school. So thank you for coming. If there is any further question, you can come to my DM. I'm dropping the notebook in the class. It's up, and I'll do my best to upload the video to tonight. Because if I don't upload it, if I go and sleep, I don't know when I'll wake up. That is if I am to wake up. Thank you very much. See you. I think yeah, I owe you one class. I'll be. Let's see whether we can meet tomorrow, or if not tomorrow, we can meet on Thursday. Yeah, because you have a meeting Wednesday. You can put that one too. Sandra, you can create a poll on that whether we want to be tomorrow, Thursday, on Friday, or Friday in the group. I beg you. Okay. Thank you guys. See you on the next meeting. Bye bye.